I'm going to talk a little bit about replication and reproducibility. I think in a lot of circumstances, people tend to use these words interchangeably, but for the purpose of this talk, and I think also for Keith's talk next, there's going to be a distinction. So when I think about replication, I think it's kind of like the usual thing that happens in science. The purpose of replication is to address, in my opinion, the kind of validity of a scientific claim, right? So if you say that X is related to Y, the first question is, well, is this claim true, right? And so you have to replicate it in another study or in a series of other studies with new investigators, collecting new data, using different analytical methods, laboratories, instruments, whatever it be. And if you have a bunch of replications and no one can find the same thing, then you think, okay, well, it's probably not true. But if everyone finds roughly the same thing in independent studies, then you think, okay, well, that's probably a reasonable claim. So replication is kind of how we've always done things, and it's still, I think, the ultimate standard for kind of strengthening scientific evidence. So that's replication. Reproducibility, in case you haven't heard the term, is what I refer to as kind of focusing on the validity of the data analysis, right? So here you have a situation where data are collected and they've been analyzed by someone else and they say something like X is related to Y. So here, the idea is that you can have new investigators, but you look at the same data and use the same methods, perhaps, see if what they've claimed is actually produced from the data and the analysis. So the real question, I think the question here is not so much is the claim true, but really, can we trust this analysis? Okay, so that's kind of, what I see is the key question that reproducibility tries to address. Can we take their approach, apply it to their data, and get the same thing that they've gotten? And I think this is key. Reproducibility is particularly important in my area of work, where replication is just not possible. So this is where I'm starting. And just so I think some background that everyone's familiar with, there's been a lot of talk about reproducibility in recent years. Some of the trends are just kind of, a lot of studies just can't be replicated, they're huge. Especially in kind of epidemiology, you have these 25-year cohort studies, they just can't be replicated in a reasonable amount of time. There's a lot of technology which is affecting the rate of data collection. The complexity of the data is very high. You have these kind of databases that people are just merging together like crazy. I mean, I'm one of those people. And I'm seeing a lot of these data are used off-label. So, for example, you have administrative data sets that are being used for health studies, things like that. So this is very common. And then because it's inexpensive, computing power is very sophisticated now, so we can do very kind of complex analyses on just small data sets. And then for every field X, there's a computational X now. So just some of the results of basic analyses can be very difficult to describe now in just kind of like your standard methods section in a journal. Oftentimes, there's very heavy computational requirements that are thrust on people with very little training. So just a little bit of the context that kind of, from where I'm coming, I think if you think of the range of kind of computational ability from low to high, most of the people in this room are over here. All the people in this room are over here, maybe Jeff's over here. But there's a whole slew of people on this end of the spectrum who are doing computational, who have to do computational work for whether they like it or not, and the reason is because they've got all this data coming in. And so that can lead to problems. You can have errors introduced into the long-term analysis pipelines. And if you can't tell people what you've done in a reasonable amount of space, that kind of inhibits the transfer of knowledge. So in many cases, there's a sense that complicated analyses can't be trusted.